Okay, so the first thing that we're doing should be a little bit of review. We're just going to look at the distributive property one more time before we get into something new, kind of in the second half of class. So this is what I was saying that like has been the make it or break it today as far as like getting a break. Because I've had to go a little bit more detail than I intended, but that's okay because I want to make sure that we're pretty confident on this before we move on to something new. So if I look at this expression that says 2 times 13 plus 5x minus x squared minus, and then x squared minus 4 in the second set of parentheses. Before I combine any like terms, I need to do one thing, and that would be to use the distributive property. And my stylus broke, so I'm using my finger. See that? So I apologize if it's not like as nice handwriting as you're used to. So if I were to use the distributive property, I'm going to take this 2 and I'm going to distribute it to all the things inside that set of parentheses. So 2 times 13 would be 26. 2 times 5x would be 10x, and 2 times minus x squared would be minus 2x squared. And then what are you distributing to the second set of parentheses? Yes, -1, good, yeah, -1 to both of those set of parentheses, or both of the things in that set. So -1 times x squared would be minus x squared. -1 times minus 4 is going to change that to a plus 4. That is familiar, right? We've done this in here. Good. Okay. Now, one thing that's a little bit different is we are going to combine like terms. 22. Specifically, it says to write it in standard form. So think back to Thursday. What does standard form mean? What does standard form mean? Yeah. Yeah, the highest degree or exponent, descending until we get to the smallest degree or exponent. So if we're looking here, what is the highest exponent? Kingsley? 2, yeah. And how many terms do we have with an exponent of 2? 2 terms. I have minus 2x squared and a minus x squared. So I can combine those because they're like terms to get -3 x squared because I have -2 minus 1. Our next highest exponent is a 1, which the only x to the first power we have is that 10x, so plus 10x. And then our last highest exponent is an exponent of 0 because our constants have a degree of 0. So 26 and 4 would give us 30. So the answer, we can't do anything else, would be -3x squared plus 10x plus 30. Ready to try another one? You sure? Okay, let's do it. So let's try the next one. So for the first set of parentheses, I'm distributing a 2x. Oh yeah, sorry, same question. What do we need to do before combining like terms? Distributive property. I have a question. What's x times x? That would be x plus x. X times x. X squared. The reason why is x times x, both of these have an exponent of 1. If you add those together, you get 2 for squared. Good. Okay, I just want to make that clear. So if I have negative 2x times 4x, that would be negative 8x squared. Negative 8x squared. Negative 2x times minus 9 would change to plus 18x. And then for my second set of parentheses, I'm distributing a 3. 3 times 7 would be 21. And 3 times minus x would be minus 3x. And again, I want you to be comfortable writing in standard form. So here, the biggest exponent is 2. And there's only one thing that has an exponent of 2. Negative 8x squared. There are 2 things that have one exponent. 18 minus 3 would be 15x. And then our constant is going to go at the end, which was 21. How are we feeling? Good. Okay, let's try. We're going to do maybe like 1 or 2 more together. Then I'm going to have you practice some on your own, okay? We're going to get a little more complicated. So let's look at letter A. So for that first set of parentheses, we're going to distribute our negative 3. Negative 3 times 6x squared would be negative 18x squared. Negative 3 times negative 10x would be plus 30x. Good. And negative 3 times positive 9 would be minus 27. Yeah, math is hard sometimes. And then for our second set of parentheses, we want to distribute 8x. 8x times 3x is 24x squared. Remember, 1 plus 1 would give us x squared. And then 8x times 4 would be plus 32x. Good. If you're getting that step right, that is amazing. It's just the combining like terms part that you need to fix if you're having integer issues. So our biggest exponent is our x squareds. So we have negative 18x squared and 24x squared. If I combine negative 18 and 24, I end up with 6x squared. And again, we're doing standard form. So our next term should be our x terms, 30x and 32x would be 62x. And then our last thing would be our minus 27, which is our constant term. Good, y'all are doing awesome. Okay, last one together, and then I'll let you try a couple on your own. Whew, this one's a little bit more complicated. Okay, let's just focus on the first set of parentheses. So we're going to distribute 3a squared b to the 5th to both of those terms inside the parentheses. So the coefficients, 3 times 2 is, yeah, 6. That wasn't a trick question. 3 times 2 is 6. What should we do with those exponents? Add them. So for my a, 2 times 4, or plus 4 would be a to the 6th. Good. And then for my b's, I have 5 plus 1, which would also be b to the 6th power. And then if I take my 3a squared b to the 5th to my second term, 3 times 5 would be 15. A to squared and a to the 1st would give me a to the 3rd. B to the 5th, b to the 1st would be b to the 6th. Then I'm going to put my minus sign, and then we'll talk about that second set of parentheses in a second. Give everybody a chance to get there. Okay, all of that is being squared. So the coefficient 9 squared is 81 because you multiply it by itself if it's a coefficient. For our exponents, we multiply 3 times 2, which would be a to the 6th. And for b, 3 times 2 would be b to the 6th. Do you have a question? Are you sure? Yeah. Okay, just want to double check. This is where I had to take most of my time earlier today. So I want to make sure everybody's clear on especially the exponents where I'm getting I'm not just making those numbers up, to make sure you know where they're coming from. You good? Is that a yes? Okay. Now, can I combine anything? Madison?
Yes.
What can I combine?
You can combine 6a.
I know it's a mouthful. 6a to the 6th, b to the 6th with what?
Negative 81 a to the 6th.
Yes. Why am I only allowed to combine those?
Because they have the same exponents.
And correct. So although all of them have an a and a b, I can only combine things that also have the same exponents on those variables. So notice how these have a to the 6th, b to the 6th, and these also have a to the 6th, b to the 6th. Yeah. How did I get 6 on which one? These two? Because when you're raising an exponent to an exponent, you multiply those together. Yeah, so it's 3 times 2 and 3 times 2. Okay. So 6 minus 81. Negative 75. And you do not do anything with the variables or exponents. A to the 6th, b to the 6th. And then we still have plus 15, a to the 3rd, b to the 6th. And then I can't do anything. That's it. I can't combine those. I can't, unless I told you what a and b were equal to, which I'm not. You're done with that part. Okay. All right, listen carefully. I only want you to do the try it letters A and B. Okay, so let's look at letter A, which I think by this point, okay, thanks, Terrence. By this point, I've seen most everybody's answers. So that first set of parentheses, technically you're multiplying by 1, so it's not going to change any values of the first set of parentheses. So we still have 8x to the 5th plus 4x to the 3rd minus 7. The second set of parentheses, though, we are multiplying. We're multiplying by -1. So that would be minus 11 plus x to the 3rd minus 5x to the 5th power. And then you had to combine like terms. I will tell you, the biggest issue I'm seeing with the combining like terms is people want to add and subtract their exponents. Don't do that. If I'm combining 8x to the 5th minus 5x to the 5th, my answer would also be 3x to the 5th, not 3x to the 10th, 3x to the 5th. If I'm combining my x to the 3rds, 4x to the 3rd plus 1x to the 3rd is 5x to the 3rds, not the 6th, the 3rds. And then minus 7 minus 11 would be minus 18. Okay, and that was the answer. 3x to the 5th plus 5x to the 3rd minus 18. Awesome. Okay. I had a few of you get through letter B, but let's do it together if you haven't looked at it yet. So in the first set of parentheses, I'm distributing 4x. 4x times negative 9x is negative 36x squared. X squared. What is 4x times 5x squared? Well, I hope you realize it's 20. 5 times 4. What would our exponent be? Kingsley, you think you know? Yeah, x to the third power. It's to the third power because 4x has a 1. X to the first times x to the second gives me x to the third, correct. And then 4x times 3 would be 12x. And then in our second set of parentheses, we're distributing 7. So 7 times 13 is 91. 7 times 5x is 35x. I'm running out of room. And then 7 times minus x squared would be minus 7x squared. And again, we want to write it in standard form. So our biggest exponent is 3, so 20x to the third. And then our next biggest exponents are x squareds, and I have 2 of them. Negative 36 and minus 7 would be minus 43 x squared. Our next biggest exponent would be our x's, which would be 12 and 35. Oh, I changed the wrong color, dang it. 12 and 35 would be 47x. And then we have our constant of 91 at the end. So 20x to the third power minus 43x squared plus 47x plus 91. Woohoo! These should look familiar. Yes? Yes. Okay. So, like I said, these are called algebra tiles. Algebra tiles are extremely useful, but as you can see, they're pretty time consuming, right? Especially if you have to drag, how many were you doing, Graham? 15 of them or 12 of them or whatever. Oh, Viente trace. Did I say that right, Kylie? I think I did. I don't.
Yeah, you said it right.
Yes, sweet. Thank you. Thanks, Enrique. Viente trace, according to Kylie and Enrique. Oh, Renee said they dragged 27 of them, of the things over, yeah. So, although important to see, not realistic to do for every single problem, right? Hey guys, if you're on your computer, you don't need them right now, so thank you. So we have our 3 tiles. We have our 1 unit tile, so we're gonna write a 1 in there. Because length is 1, width is 1, area would be 1. Our X tile, our length is X, our width is 1, so the area would be X. And our X squared tile, our length and our width are both X. X times X would be X squared. Okay, so we want to sketch what 2X plus 4 would look like. So we have 2 of our X tiles, and then 1, oh, that doesn't look like a square. 1, 2, 3, 4. Oh, that's a pentagon, but that's okay. 4 of our 1 squares. So that picture-wise represents 2x plus 4. What if I asked you to represent 3x minus 5? Well, we would obviously draw 1, 2, 3 x's. How could I represent minus 5? How could I represent minus 5? Anybody have an idea? Just the way I would represent 4, except of putting a 1 in there, I'd put a negative 1. Yeah, so 1, 2, 3, 4, 5, and each of these I would put in a negative 1. That's a lot of work. We're lazy. We don't want to do that work. So let me show you the same concept, but easier than drawing each individual piece. So we have this picture. If you turn the page, that should look really familiar. Okay, we just did this. You may not have not gotten this exact one, but similar to one that you did. The top row, what does that represent? What expression? X plus 4, right? X plus 4 times the left-hand side. What is represented on the left-hand side? X plus 4 again. There's 1 X tile and 4 1 tiles. So it is x plus 4 again. So technically what I'm doing is I'm multiplying x plus 4 times x plus 4. And to get the answer to that, the only way you know how right now is to fill in this middle part with the tiles. So I have how many x squareds? 1x squared. How many x's? 8 x's. And how many 16s? Or how many 16s? How many ones? 16. And if I were to write that as a polynomial, I would write x squared plus 8x plus 16. So Graham, since you're so passionate about, why do you think it's called the area model before I answer this question? Why is this called an area model? What are you doing? You're multiplying. You're multiplying a side times a side. Well, that sounds a whole lot like an area. So you're finding the area. Graham, why would it not be practical to use tiles to represent 15x minus 9 and 3x plus 24? Because it's what? Yeah, it takes a lot of time, especially when we have to multiply 24 times 9, which is like 216. You'd be dragging 216 ones over to that little thing. Yeah, I would never expect you to do that. So I'm going to come up with for you a different way to do this. So that is not practical because it's too much time. Now, the second example is not too big. Why is the second example not practical to represent using the tiles? There's too many different variables. We can't use x squared. We can't use an x tile and a z tile, the same shape, because they can't represent the exact same thing. So there's different variables for the second one. And again, I apologize for my handwriting today. My stylus is broken, so we're just dealing with it. So let me show you the most amazing thing you're ever going to see in your whole life. Okay. I hope you're ready. So I want you to draw a box. And I want you to cut that box into fourths. You may or may not have seen this in elementary school at some point when you're multiplying. Are you waving at me, Jonathan? Or are you just like doing some random stuff? Okay. When you were multiplying 2-digit numbers, you may have seen something similar to this. If you had a great, amazing teacher in elementary school. Not saying that your great, amazing teachers didn't show you this, but if they showed you this, then they're extra great and amazing. Okay. So 15x and minus 9 are going to go above the box.
Oh, yeah.
I'm glad you've seen this before. Yay. And then 3x and 24 are going to go on the left-hand side of the box. And what we're going to do is we're going to multiply each individual piece together and then add up the whole thing to get our answer. So 3x times 15x would be 45x squared. (3x times negative 9 would be negative 27x. 24, and I'll cheat for you. 24 times 15 is 360x. And then you're right, Thorn. 24 times negative 9 is negative 216. So all we did was we multiplied the terms that were together for each of the boxes. Are we done? Almost. So we want to write in standard form. Inside the boxes, what's our biggest variable? 45x squared. What would come next? Well, I have two x terms, right? And I can combine them. 360 plus negative 27 or minus 27 is 333x. Remember, if we're adding negatives, we're subtracting. Minus 216. And that is it. Yay. Woo. Woo. Okay, so let's look at another one. We're going to practice a few. I'm going to skip down to the let's practice. X plus 5 times x plus 2. So I'm multiplying a binomial times a binomial. So I should have a 2 by 2 box. So here's my box, 2 columns, 2 rows, 2 by 2. I'm going to put x and 5 at the top and x and 2 on the side. X times x is x squared. And you were doing this exact same thing with the algebra tiles. You just didn't know it. 5 times x is 5x. So instead of just writing 5x, you were dragging 1, 2, 3, 4, 5 x's, right? X times 2 would be 2x. You were dragging 2 x's. And then 2 times 5 would be 10, and you'd be dragging 1, 2, 3, 4, 10 ones. Did you do this one?
Yeah.
Oh, okay. So if we wrote in standard form, we would have x squared. We can combine our x's. 5x and 2x is 5x plus 2x is 7x. And then plus 10. Feel better, Graham, than before? Less brain power. Okay. Esteban, you good? Are you sure? Need me to clarify anything? Okay. Okay. What does that mean? X minus 7 squared. What is that asking me to do? Ella?
Multiply x times 2, negative 7 times 2.
Okay, I don't disagree. When you square something, what does it mean? Multiply it by itself. So we're going to see, Ella, if what you're saying is the same thing. But I want to write it out first. So x minus 7 times x minus 7. So I have a binomial and a binomial. So I need a 2 by 2 box. So I have x minus 7 and x minus 7. X times x is x squared. X times minus 7 would be negative 7x or minus 7x. X times minus 7 again would be negative 7x. Negative 7 times negative 7 is 49. So we have x squared if we're writing in standard form. I can combine. What's negative 7 and negative 7? Negative 14x plus 49. Now, is that the same thing as distributing that squared to the x and the 7? So that would give me x squared plus 49. Is that the same thing? It is not. So this distribution only works when you have things multiplied together in the parentheses. If you even look back in our exponent operations notes in your book, I think it was page 9. If you look at the one where we distributed the exponent, so power, I think it was power of a product. Notice how the only things that we gave the exponent to were things that were being multiplied together. We never distributed that exponent to things that were being added and subtracted. So you must write it out like this and then use this area model to multiply together. You can't just distribute that squared to those things inside the parentheses. Okay, let's look at one more and then I'm gonna have you do 2 on your own and then we'll be done for the day. Uh-oh. Yes, sir.
Wait, so why does it only work again? I was gonna write it down.
So you only can distribute an exponent when you're multiplying things together. You cannot distribute it when you're adding and subtracting. Good? Okay. How big is my box gonna be? 2 by 3, because I have a binomial times a trinomial, 2 terms times 3 terms. So here's my box, here's my 2, and then my 3. So I'm essentially gonna have 6 boxes, 2 by 3. At the top, I'm gonna write my trinomial, 5x, negative 6xy, negative 7y. On the left, I'm gonna write my binomial, 3y and 2x. All right, so let's start multiplying. 3y times 5x would be 15. And I'm gonna do xy because we usually go in alphabetical order. X comes before y. Someone in my 3rd period did know that. I'm scared for them too. XYZ, it's the alphabet. 3y times negative 6xy would be negative 18 x y squared. We're getting y squared because we have y to the first and y to the first. When we combine those, we get y to the 2nd power. And then 3y and negative 7y would be negative 21 y squared. So that's our top row. Our bottom row, 5x times 2x would be 10x squared. 2x times negative 6xy would be negative 12. This time not xy squared, x squared y. And then our last box, 2x times negative 7y would be negative 14 xy. All right, so let's write it out. First, before we write it out, do you see any like terms in any of those 6 boxes? Kingsley, you're shaking your head, yes. Which ones?
15xy and negative
14. 15xy and negative 14xy. None of the other ones are like. So we literally are just gonna write them in order. I wouldn't say that there's a standard form for this question, only because there are 2 terms whose degree is a 3. The xy squared would be degree 3 and the x squared y would be degree 3. So I wouldn't necessarily worry about standard form here. We just want to make sure we have all the terms right. So what is 15xy plus negative 14xy? Just an xy or 1xy minus 18xy squared minus 21 y squared plus 10x squared minus 12x squared y. Whew. Yay. Holy cow is right. Yeah.
Holy geez.
Okay, so here's what I would like you to do. Listen carefully. I want you to do number 1 on the try it. No, I lied. Number 4 on the try it. And then if you turn the page, I think is the beat the test on the next page. Just number 1 on beat the test. Everybody hear me? 4 on try it, 1 on beat the test. Let me know when you're done and I'll check your answers.